Let us solve these questions under determinants. On this 4.4, we are instructed to find variable a and b using only Kramer's rule from these given equations. So let us rearrange these equations so for us to be easier to solve. The first equation. This 7a must be a first on line from across equal sign, whereby it will change to be positive 7a, followed by negative 6b. Then move negative 27 to across equal sign, where it will be settled as positive 27. On second equation. 3a must be first in line, followed by 4b, and move this negative 5 to across equal sign whereby it will change sign to positive 5. So these numbers across equal sign are called constants because they have no variables alongside with them. And these other numbers have variables which are a and b which we are to find. Because we have two variables and two equations that lead us to 2 by 2 determinant. So to find determinant, we put these coefficients for a on first column and coefficients for b on second column like so. Then evaluation follows. 7 multiply by 4, then apply minus sign, thereafter you multiply this 3 with this negative 6. These get us the determinant to be 46. Then we move to find determinant with respect to a. So, to find that, you will take this determinant for coefficients, and replace only the coefficients of a, which are in column 1, replacing them with these constants like so. Then evaluation follows. 27 multiplies by this 4, apply minus sign, thereafter you take this 5 multiply by negative 6. We get determinant with respect to a, to be 138. Lastly, finding variable b, we again take this original square matrix, and replace only the coefficients of b on second column, replacing with these constants. Evaluation follows. 7 multiplies by 5, minus, then 3 multiplies by 27. We get determinant with respect to b, to be negative 46. Now, we go to these formulas to get these variables required. We say, a equals this 138 divided by this 46, we get a to be 3. As for b, we say, b equals negative 46 divided by 46, we get b to be negative 1. That is what 4.4 was looking for. Now on 4.5.1, we are instructed to find the value of determinant by expanding on second column on this 3 by 3 matrix. You will need sign factors when busy solving this. Let us take this table for sign factors, whereby we will be using the middle signs as we are expanding along column 2. We strike out column 2 and row 1, then we write the minor left alongside with this negative 1, remember here the sign factor is negative also. When we strike out row 2, the lines meet at this 2, this is a group of elements left out, whereby the sign factor is this positive. Then we move to strike out row 3, which means we have this negative as sign factor and also this 8 is negative, and this is the minor associated with this element 8. From this point, we use evaluation of 2 by 2 determinant. That will be this negative 0.25 times this 0.666, then apply minus, thereafter it's this 5 times this 0. On this minor, we say, this 0.666 times this negative 0.666, minus, 5 times this negative 0.5. This last group, this 0.666 times 0, minus, then this negative 0.25 times this negative 0.5. Try to calculate all these together, and see what value you get. Calculating all these, I get a value of determinant to be 1.503. Well, that was the answer for 4.5.1. Then, on 4.5.2, we are instructed to determine the value of the cofactor of this negative 1. Well, we apply this expression to find cofactor. Then, the minor associated with negative 1, it is this first group which gave us a value of 0.1665 as value of minor associated with this negative 1. Then, the sign factor, you may take this negative here and put here as negative 1 for sign factor, but let us find this negative 1 in this way. This element is in row 1 and column 2, which give power of 3, that turn whole of this term to be negative 1 still. Then, we say, negative 1 times 0.665, which get us a value for cofactor of this negative 1, to be negative 0.665. This negative 0.665 is the answer for 4.5.2.